The first gas law that we're going to look at in this unit is called Boyles' law. Boyles' law is the relationship between pressure and volume of a sample of gas. We're going to use a simulation to show this relationship and figure it out. So as you're watching this video, I would like you to record pressure and volume readings as we go through the simulation. So if you create a table in your notebook, you're going to have 3 or 4 pressure and volume readings that you're going to record and then look at the relationship of afterwards. The other thing you're going to record for this is the temperature of the gas sample. So we're going to go into our simulation. This is a chem lab program that we have at the school. We're going to go into the gas lab. On your screen right now, you'll see 4 cylinders of gas on the right-hand side. Those are what we're going to use to fill up our cylinder, which is on the left, the red outline. And in the middle, you should see a green box with a bunch of numbers. Those are the readings for our gas sample. It's showing pressure at the top, and its reading is atmospheres. The mass of the gas, moles, temperature in units of Kelvin, and the volume in units of liters. The first thing we need to do is evacuate the cylinder of gas so that we've got very, very little gas. So we're just going to have to wait a moment while the gas comes out of our cylinder. Remember that you're going to record some pressure and volume readings. And for this simulation, we're going to keep our temperature constant at 273.15 Kelvin. So you can record your temperature beside your table, and we're just going to wait a few moments for the gas to evacuate. In your table, you can add some units onto your pressure and volume headings. So your pressure would be units of ATM, and your volume is going to be units of liters. So now that we have our cylinder evacuated, we're going to fill it up with any one of the gases. It doesn't matter which one. We want to fill it so that we have 3 liters approximately. So I'm going to click on the oxygen, and you'll see that the pressure and the volume are going to start increasing. So we're supposed to let this fill until we have about 3 liters of gas. So besides scenario 1 in your table, you can record your pressure as 1.50 and the volume as 3.14. Now if we change the pressure by dropping a weight onto the piston of the cylinder, we're going to get a new pressure and a new volume reading. So right above the green box, there's these black rectangles. Those are my weights. If I click on one of those, you'll see that it moved over, landed on the piston, and it's now compressed our gas. So beside scenario 2 in your table, you should write down 2.00 for the pressure and 2.35 for the volume. The third scenario we're going to look at is if we drop a second weight onto our piston. So if I click on the second weight, again, we've compressed our gas further. Now the pressure is 2.50 atmosphere, and the volume is 1.88 liters. So at this point, what I would like you to do is pause the recording and see if you can figure out a mathematical relationship for those 3 scenarios where you have pressures and volumes. Hopefully you figured out at this point that there is a mathematical relationship of pressure and volume. So when we have a sample of gas with volume 1 and a pressure 1, and that's compressed or expanded, so we compressed ours, down to volume 2 and pressure 2, The relationship that we want for these four variables is usually written as P1 times V1 equals P2 times V2. So this is the mathematical relationship that most people know as Boyles' law. It's very important when you're using this to make sure that you have the same units for your two pressure readings, and also for your volumes that they have to be in the same units as each other. Another important note is that the amount of gas and the temperature must remain constant to use this mathematical relationship. Let's do a couple of examples using our calculations and our formula. First one, we have a 500 milliliter sample of neon gas at 97 kilopascals. So we have volume 1 and pressure 1. And that's compressed to a volume of 450 milliliters. So we have volume 2. What is the new pressure of the neon? So we're looking for P2. That's our unknown. If you rearrange the formula up above, P2 will be equal to P1 over V1, P1 times V1 over V2. Looking at the units that you have for all of those numbers, our units match each other for our volumes, so we don't have to do any conversions. So pressure 1 is 97 kilopascals. Volume 1 is 500 milliliters. And divide those by volume 2, 450 milliliters. And calculation, rounding for significant digits, you come out with 108 kilopascals. For question 2, we're just going to do a quick conversion calculation. Practice conversion is going to happen in a lot of your questions. So new pressure, but in units of ATM. Take your 108, which is actually 107 point something 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 in your calculator. Take that unrounded number, multiply by our unit conversion factor. So we want ATM, atmospheres, so those are going to go on the top. And we're going to cancel kilopascal, so they go on the bottom. Our equivalencies are 1 atmosphere for 101.325 kilopascals. So again, using that unrounded number in your calculator, times by 1, divided by 101.325, your new pressure is 1.06 atmosphere. Let's do one more. A 2.54 liter sample of chlorine gas at 945 millimeters of mercury in a cylinder with a piston is expanded so the pressure drops to 89.5 kilopascals. What is the volume of chlorine gas? We know we're looking for a volume. That's our unknown. So back in the question, if we look at the values we have, we were given a volume at the beginning, 2.54 liters, and the pressure that it was at when it started. So that's P1. Then we expanded the gas and the pressure dropped. So there's P2, 89.5 kilopascals. So we're looking for volume 2 in the question. If we put all of these numbers in, there's a problem. We don't have two pressure units that match each other. So one of these pressures needs to be converted or changed into the other. Doesn't matter which one you do, but I'm going to convert pressure 2 so that it's in millimeters of mercury. So 89.5 kilopascals times by 760 millimeters of mercury over 101.325 kilopascals. So pressure 2 in units of millimeters of mercury will be 671.3, and make sure you keep that number from your calculator. Use the unrounded number for further calculations. Now we can do our calculation for V2. So rearranging the formula, we need P1 times V1 over P2. Pressure 1 is 945 millimeters of mercury. Volume 1 is 2.54 liters. And divide by our new pressure 2, that's in millimeters of mercury. And our answer, which will come out to liters, is 3.58 when we do 3 significant digits to match the question. The last thing we want to look at for Boyle's law is the graphical relationship between pressure and volume. Pressure and volume are inversely proportional. So as one of those variables increases, that means that the other variable is going to decrease. They move in opposite directions. What that looks like on the graph, if we plotted pressure and volume, would be a curve. So make sure you can recognize this relationship on a graph as an inverse relationship. As one goes up, the other goes down.